Thanks for coming. I see many unfamiliar names also. Then today I'm not only talk about advanced contact angle, we will also cover some basic ones which we already been in UFAB for many years. Okay, so the first slide is just the background knowledge about contact angle and how does a contact angle forms. So we're going to play a quick short video.
Well, contact angle refers to a droplet. But let's back up just a bit. There are two kinds of droplets that we ordinarily think about. You have what's called a sessile drop, and that's a drop that is resting on a surface. On the other hand, you can have what's called a pendant drop, like a pendant necklace, for example. This is a pendant drop dangling from a syringe tip or a nozzle. So this is a sessile drop. This is a pendant drop. Now, the sessile drop has a certain shape that's controlled by gravity, which will try to compress it downward. And it also, the shape of that drop is also controlled by the angle at which this liquid drop meets the solid surface. And then we can construct a tangent to that droplet as it emanates from the surface, and we can measure an angle, and that's the contact angle. Now this contact angle that we can measure, it is controlled by surface energies that we talked about previously, or surface tensions. And there are three surface tensions in this problem, because we have the liquid droplet, we have an ambient fluid, it could be air, and then we have the solid. There is a surface energy or tension right here between the ambient and the solid. That's this one right here. So this would be sigma SA. And then underneath the droplet right here, there's another one between the liquid and the solid. And then finally we have this surface tension right here between the liquid and the air. So these three surface tensions, little forces, have to be balanced at this point. And that balance of forces is controlled by this contact angle.
Okay, so just this part is just to summarize the video. So we have these simple equations, and to calculate the contact angle, if you know the surface energy and also the interfacial tension between solid and liquid, and also the surface tension of this liquid. So for something like water and silicon, so this kind of parameter you can easily Google online, and you can quickly calculate this contact angle, and you can compare with your measurement. So this is a very basic contact angle, and is usually we refer it as static contact angle, because we just drop a water on the surface, and while it's in a static mode, you just measure the shape and use the fitting of the shape to get this angle out from these curved lines. So let's go to the next one. Oh, sorry. Okay, so this kind of basic static contact angle measurements we can do with this contact goniometer, which is at NUFAB for quite many years, and this has been familiar with many of our users. So it has very simple setup with a syringe and a camera, and the sample holding is here. So this one will does very well with this static contact angle measurement. Recently, we have a new optical tensiometer. Update is a higher version of this contact angle measurement system. It's from Balin Scientific, and the model is attention theta flow. So it looks like this one. If you walk in the clean room, you may see this thing. It looks pretty big and catching your eyes. So this one is our new advanced contact angle measurement system. So then we'll talk a little bit what's the difference and what we updated from that basic one to this advanced one. Advantage are listing here, separating in hardware parts and software parts. So we'll first take a look at the hardware. So the major difference, which is really important to many of our users, is so the new system is using disposable bypass tips, and for the old ones, it's use reusable syringe and needle site. So you can imagine that this disposable one will limit the cross contamination quite a lot. And a very big difference for the stage is the tilting. Before it was only very limited tilting to use for leveling the surface. Now we can have the tilting up to 90 degrees in both directions. We also include the motorized XYZ stage, so you don't have to manually turn the knob to move the sample manually, and this system does everything, move the stage for you automatically. The camera also have pretty big upgrade from very limited resolution 800 times 600 up to the 5 megapascal 5 MP. So this is well, pretty good resolution. Well, still not comparable to your cell phone, but considering measurement, this is a very nice resolution, which will help you to do the accurate shift fitting and get accurate contact angle measurement. So we also include the video function, which has very high frame rates, because in some dynamic contact angle measurement, which you will see later, so high frame rate really make a difference. And we also have dual dispensers, which can measure two liquids on one surface. And so this is mostly used for calculating the surface free energy, but it's also make you switching the liquids much easier. Additionally, we have a quartz chamber. So that one will just like little cubic chamber holding liquid in, and that's saying the usage of this chamber will also show you later. Software-wise, we have instead of the fixed focusing with the old system, so this new system include auto focusing, which also have the manual focusing available. And instead of manual fitting the shapes, droplet shapes, it include auto shift fitting. And then so it has default video recording, so which is really important for dynamic contact angle measurement or roll-off angles. And it also have advanced data analysis to calculate the surface tension and surface free energy. Okay, so how does this advantage make a difference, and what kind of measurement it will impact? So this comes to an outline of the talk today. So we will see how those upgrades will enable us to do all this kind of measurement or make a difference in this kind of measurements. So for static ones, we have those sensor drops and dynamic ones. So we'll go through it one by one. So this is how the static contact angle measures with old system. So this is a picture captured by the video. And then if you ever use it, you will know that the next step is you're gonna manually move these 5 markers around the droplet, and then click a calculate button. So this one will fit the curve. So the red curve should be overlap with the shape of the droplet. But the judgment is made by your own hand and your own eyes. And then this is some uncertainty, and maybe different people will put them at different place. And then this will introduce some user-dependent errors. With this, and also because it's used reusable syringe and needle side, so everybody shares. So we're trying to give each liquid a syringe, but if it still can happen that somebody not doing it practices well enough, it could cause cross-contamination. So with this new system, all those things are eliminated, and this is how it measures this basic contact angle with this new system.
Attention Theta Flex is a contact angle meter optimized for simplicity in use. It measures interfacial properties such as contact angle and surface tension. Contact angle measurement is commonly used to evaluate surface quality. In a contact angle measurement with Theta Flex, the sample is first placed on the sample stage and brought to image. Before putting a droplet on the sample, Theta Flex can automatically inspect the liquid for contaminants. A droplet whose volume is controlled by analyzing the shape of the pendant drop is then created and deposited smoothly on the surface. All parameters are present for a quick start, but can also be modified by the user. As the droplet is being placed, the One Attention software automatically starts analyzing the contact angle of the droplet on both sides to show the results immediately. Analysis can be done with multiple analyzing modes, such as Young Laplace and either automatic or manual baseline. The results are saved in a library and can be compared and presented with ease.
Okay. Next slide.
Attention.
All right. So again, so the contact angle is not limited with this basic static contact angle measurement. It also have more than that. So this slide is showing why we should consider more than just static contact angle. So the left side is showing the free energy of a whiting system between an ideal surface and water and air gas. So this whiting system has only one single free energy minimum. So this is where the stable contact angle is shows, and this is the basic one. So which is usually measured by the basic ones that you saw before. But actually in the real life, the real surface is not this ideal. So ideal surface, we're usually referring to a very, very smooth, atomically smooth and chemically homogeneous and not reactive and not deformable by liquid. But in the real case, there's a lot of things can happen. And then the free energy curve is not smooth anymore. Instead of having only one minimum, it has one global minimum, but it also have many local minimums. So this is a meta state can also can also trap the liquid and showing you a contact angle. And by just disposing a liquid onto the surface, you can measure any of those little local minimums. So this will make the measurement not reproducible, because every time if you pour different minimum, you get different results. And in this case, only reproducible measurement is a dynamic contact angle. Okay. So referring to dynamic contact angle is usually talking about two terms, which is advancing contact angle and the receding contact angle. So advancing contact angle is a maximum value of a static contact angle can have, and the receding is a minimum value for the contact angle can have on the surface. So when we're talking about the maximum and minimum, so very intuitive measurement is to do a tilting. So if you tilt the sample and then the sample, the liquid will tilt with you, and then you have a bigger a bigger angle here and a small angle over here. So this advancing angle is talking about at the moment that this liquid start to slide off and the maximum contact angle it can reach. So the measurement is pretty simple, easy to perform. So first you place a drop on a sample surface and then you start tilt it little by little. And then you just taking the video all the time, so you capture the critical point that when the drop slide off, and then at that frame, you can analyze and get the advancing and receding angles. So also this measurement can also tell you what's a sliding angle, or if you have very hydrophobic surface, it also tells you the roll-off angle. So this measurement is easy to perform and very intuitively explained, but it also comes with its own limitation because it's natural that this advancing and receding contact angle, they may not reach at the same time point, at the same time tilting angle. And also when you do this one and you think when you're tilting it off, the gravity is playing a role here. So different volume or different weight of the drop also impacts the reading of this contact angle. So then people comes with a better idea to measure this one, which is called needle-in method. So this one is using a relatively small droplet. So it keeps the needle inserted into the droplet, and then it starts to fill in more liquid, and then the droplet will grow. So at beginning, this point are pinned on the surface, but at some volume that it will not hold anymore, and then this slide, so the front moves away. And at the sliding point, the maximum contact angle it can achieve is advancing contact angle. If you want to measure receding, so it's just a reverse process. You still keep the volume, keep the needle in the droplet, and then you suck out the liquid. Then the droplet shrink. So at beginning, it's still pinned onto this point, and at some point, and the pinning point moved inward. Then at the critical changing point, that's the receding contact angle. So this one is measures more reliably because it separates the advancing and the receding, and also it's use a smaller droplet, so you don't have a very big sample. But disadvantage is that this protocol, to do this measurement, you need to follow a very strict protocol. Otherwise, you can introduce some operator error. So this is something really details that if you're really interested in, and during the training, we can go through the protocol. So I will play a video to show you how in the real life, how those methods are practiced. Okay, so
commonly referred to as dynamic contact angles, are often used for quantifying the level of surface heterogeneity. There are two main methods to obtain these values with ThetaFlex. The first option is to use a tilting paddle or a tilting stage accessory. A droplet is placed on the sample surface and tilting is started. Once the droplet starts moving on the sample surface, the advancing and receding contact angles have been reached. The roll-off angle of the surface is also detected. Another method is to use a thin needle to dilate and contract a droplet on the surface. When the droplet is being dilated, it forms the advancing contact angle. When the droplet is being contracted, it will reach the receding contact angle instead. ThetaFlex has a special measurement mode that performs it fully automatically all the way from introduction of the droplet into the analysis of the advancing and receding contact angles.
Okay. All right, let's go back here. All right, so after talking about the contact angles, now we can look at surface tension. Surface tension is only to describe the liquid, so we don't have a sample here. Surface tension is pretty a very standard parameter to quantify a liquid, and the measurement is usually done by a pendant drop. So in the pendant drop, this is a balance between the weight of the droplet and the tension of holding the droplet, the surface tension. So to measure the surface tension of the liquid, we're looking at the maximum weight, the maximum gravity that can be balanced by the surface tension. So the measurement is first you will dispense a liquid as big as possible. You're looking at the size just be smaller than the breaking point, and at that point you take a picture of the droplet and you measure the shapes. So there's some numbers showing here comes with this droplet shape, and basically you're gonna balance. You're looking for the balance between the gravity and the weight. So we also have the density of the liquid here. So then you just leave everything else to the software, and it will just automatically analyze the shape of the droplet and plug in the weight, and then you can get the surface tension as a column showing here. So this is a screenshot from our software showing you how the water droplet looks like, and the fitting by this curve, and then it automatically generates the column with the surface tension for water. Another way is similarly interfacial tension, which talking about in the interfacial between two different liquid. So it depending on how the droplet will pointing down or pointing up. So we have this also have this this hook that curving up, that you can even measure a bubble within a liquid. So this is happens in the quartz chamber, so which have a very excellent optical properties that even in the liquid, in the chamber, you can still capture a very clear picture of the bubble or the droplet, and then you can calculate the surface interfacial tension for between these two liquid, or the air between the gas and the liquid. So this one is so usually most of the samples are just a planar, like a flat surface, but it also comes with not irregular shape. For example, we have thin fibers. It's really hard to drop the liquid onto something like this. And then this comes a different method of measuring thin fibers contact angle. So we're still using this quartz liquid, quartz chamber, and you insert this sample into the water, and at the surface you can see the water surface curves up, and this is how to measure the contact angle over here. The last measurement is surface free energy. So this one, instead of describing a liquid, is to describe the solid surface. So this is so if you ever optimize a coating process, or optimizing something like coating layers of film, so surface free energy is playing a very important role in the drug, or in the for example the cars, windshield coating, something like some functional materials. And this this parameter is a decisive parameter for the wettability of the solid. To determine the surface free energy, so a typical method is to measure contact angles, but you're gonna use at least two liquids, two known liquids to measure the contact angle. So here I'm showing this the formula to calculate the contact angle again. So at this moment, this number is an unknown number. So if you know all the rest of them, then you will be able to calculate this number. And let's quickly show you a video about how to measure surface free energy with the contact angle system. Sorry again. Here. Right.
Surface free energy, SFE, can be used for predicting the wettability and the adhesion of the solid surface with different liquids. OneAttention software calculates the surface free energy based on the contact angle results obtained with different liquids. When measuring contact angles, OneAttention uses an automatic smart mode to detect the equilibrium contact angle and uses it to calculate the SFE automatically. After making the experiments, the data from various measurements can also be easily combined into one SFE calculation with a few clicks. OneAttention then shows the surface free energy with all the most used SFE methods in a simple comparison table.
Right. All right. Here comes the summary for today, and we just give a quick comparison of these two systems. And when you are using them or applying for training, you can choose whichever one works best for you. So again, we still keep this simple contact angle goniometer. So, but we want to limit the liquid to water only. We don't want to have other liquids to introduce possible contaminations. And because of the limited contact angle measurements, so this method works only good for simple and smooth surface, and it only does static contact angle measurement. Because everything is manual and you can't measure too many contact angles, because each one you have to manually take the picture, manually place the markers, and manually fit it. So each measurement will take you about 5 minutes. You can imagine that you can't take hundreds of measurements with this one. It's gonna be too much pain. But with this one, if you have a little bit more requirements, more than water on ideal surface, you should consider this new system. So for this one, as long as your liquid is chemically stable, so it should be able to go into the system. And because of the dynamic contact angle or everything else, you can measure complex surface or the fiber-like samples. And it can take the video, so which means the measurement results will be able to do a time-dependent measurement, and everything is automatic. So then you can do a batch measurement, and the system will just measure it one by one and calculate one by one for you. So it's gonna save a lot of effort if you have a lot of samples. Additionally, if you want to measure more than just the contact angle, so this one also gives you can measure surface tension, interfacial tension, and surface free energy. So which just describes a liquid only or the surface only. Okay, so with that, it's the end of my talk today. So any questions?